Hey, good morning. Uh, my name is Sagar Dalvi, and today we are going to discuss very simple topic in Java, that is data types. Basically, Java support both primitive as well as non-primitive data types. Example of non-primitive and primitive data types we are discussing now. So, primitive data types examples are class size array. We will going to discuss primitive data types in next classes, and today we are going to discuss the non-primitive data types. Uh, the first question is Java support both primitive as well as non-primitive data types. It is itself indication or indicator that Java is not pure object oriented language. Similar question but slightly different wording. Is Java object oriented language? Then the answer is yes. Java is absolutely object oriented language. But is Java 100% object oriented language or pure object oriented language? Then the answer is, in my opinion, no. Because if Java is a pure object oriented language, then everything written in terms of object, as name itself indicate that object oriented language. But here some non-primitive data types as well as primitive data types supported by the Java. Therefore, we can conclude that Java is itself not a pure object-oriented language. Then there is a classification for data types of non-primitive. Non-primitive data types are generally classified into the numeric data types and non-numeric data types. Again, numeric data types are classified into integer and floating, and non-numeric data types are boolean and character. Okay, so the again to represent integer, Java has four type of data types. First one is short byte, second one is short, third one is int, and last one is double. Sorry, long. Double is in the floating. So, one question may comes in your mind: why these four types of data types provided by Java to represent only integer? So, answer for that question is simple. As we know that the range of variable uh, differ, or the requirement for the number is different in different projects. So according to our requirement, we can choose any one of the data type for integer. So let's discuss in briefly all four types of the integer. The first one is short. First one is, sorry, byte. As name itself indicate that byte means 8 bit. So in 8 bit, the first bit is for whether the number is positive or negative. That bit is called as most significant bit, MSB. So the first bit is used for whether the number is positive or negative. Remaining 7 bit are used to represent a number. So we can conclude that the range for byte is plus 2 raised to 7 to minus 2 raised to 7 to plus 2 raised to 7 minus 1, and if we calculate that number, we get minus 128 to 127. So the next immediate question come in your mind: which in which condition the byte is the best option or choice to use? Uh, then the answer for that is, uh, when we handle the files or transfer the data across the network, then short is the best choice for us. Okay. Then next data type is short. Okay, as size of earlier, that is for byte is 1 byte, and size of the short is 2 byte, that is 16 bit. So the range for short is um, 2 raised to 17 to 2 raised to 17 minus 1. And if we do calculate, then it will become minus 3 to 768 to plus 3 to 767. Okay. As similar, the first bit is a significant bit, that is MSB, which is used for to check the whether number is positive or negative. And when short is the best choice, as we know that the Java was developed in around 1995. At that time, processor 886, 885, those processor also was of 16-bit. So that time, this short is frequently used. Uh, but as technology develop or word develop, these 886, 885 processor becomes obsolete. That's why these short data types also very rarely used in entire Java or in entire Java programming industry. The less used data type is short. Okay. Uh, and next data types is uh, int int. Size of int is 4 byte, and range of int is uh, minus 2 raised to 31 to plus 2 raised to 31 minus 1. If you do calculation, then it will become minus 21 47 48 36 48 2 minus 21 47 48 36 47. Actually this is a large number. 10 number actually a large number. But sometimes we required large number than the integer. For example, if we have a problem, calculate the distance traveled by light in a 10 year in meter, then integer is not capable to hold such a large value. That's why we need large data types than the integer. Then the Java, then we have uh, the big data types, that is long, which is 8 byte, means double of the integer. And again the range is on the similar formula, minus 2 raised to 63 to 2 raised to 263 plus minus 1. Okay. So in this way we have covered all integer data types, and we observe that we don't use fractional integer or fractional part in integer data types. So to handle the fractional data, we have another two types of data types. First one is float, and second one is double. So in integer, no decimal point is used, and in floating point data types, we address the issue of decimal point. It is fractional part of the number. Okay. So we have the two types of uh, floating data types, float and double. In integer, we normally use next data types according to their requirement. Means if the number is greater than byte range, then we go for the short, and if the range is greater for the short, then we go for the integer, and if the value cannot store in integer, then we go for the long. Then according to size we choose our data types. But it floating point, size doesn't matter to use whether float or double. It's totally dependent on the precision that we have. Means after decimal point, up to what number we require precision. For example, if we require 4 to 5 places after the decimal point, then we go for the float. And if we require the large precision, that is 15 to 16 places after the decimal point, then the best choice for us is double. Means the single precision in float and double precision in the double. And next difference is the size of the float is 4 byte and size of the double is obviously 8 bytes. Okay. Then the range is also different. For the double, size is 1.7 into e raised to power 304 to 1.7 e raised to power minus 304. Whether e, what e is indicate here is the exponential value, means 10 raised to power. Okay. And the size for the float is 3.4 into e raised to power 034 to 3.4 into e raised to power minus 3 minus 34, which e raised to power minus 34. Okay. In this way we have covered all integral and floating points. I would like to mention here one point is only integer and floating have sign bit.